Hello students, welcome to my channel. In the first video, I discussed about the basic trigonometry, and here I discuss about the ASTC rule, and today I am going to discuss about the application of ASTC rule. How can we apply the ASTC rule in numerical problems? So for your better understanding, you see the video till to the end, and please like, comment, share. So here the application of ASTC rule. To apply the ASTC rule, we can break the angle in two ways. One is even multiple of 90 degree and another is odd multiple of 90 degree. Say n into pi by 2 plus or minus theta. Theta is the acute angle. If you break the angle like n into pi by 2 plus or minus theta, here this n may be even number or it may be odd number. If n is even number, the ratio, trigonometric ratio given in the question, ratio remains same. But if n is odd number, the ratio will change. Like if here it is sine, then it goes to cos. If here it is cos, it goes to sine. And tan goes to cot, cot goes to tan, sec goes to cosec, cosec goes to sec. We have to find out the value of sine 300 degree. Sine 300 degree. So this equal to sine, we can break 300 degree. Suppose 4 into 90 degree. Then 4 into 90, 360. 360 minus 60 degree, that is 300. Here you see the 4 is even number. That's why ratio sign remains same. But whether it will be positive or negative, that can be determined by applying the ASTC rule. And you know, in the last video I told you that angles are measured from the positive direction of x-axis. Since here is 4 into 90 degree, let us see where the angle lies. 4 into 90, you start from the positive direction of x-axis like this. 190, 290, 390, 490, up to this 490. Then here it is minus 60, that's why you just break and go like this. Then you arrive at the fourth quadrant, and in the fourth quadrant we know that cos ratio is positive. Here it was sine ratio, that's why it will be automatically negative. So ultimate result will be minus sine 60 degree. And you know the value of sine 60 degree? Minus. So sine 60 degree, it is root 3 by 2. So result will be minus root 3 by 2. Or alternately, you see, if you break the angle now, it is suppose odd multiple of 90 degree, then what happened? Sine, say, let us break this like 3 into 90 degree. 3 into 90 is 270. 270 plus 30, that is 300. So now here you see the number, this one 3, it is odd number, and whenever it is odd number, I told you earlier that ratio will change. Sine goes to cos. At the same time, 3 into 90 plus 30, where the angle you see? 3 into 90, let us start from this one. 190, 290, 390, then plus, go forward, you arrive at the fourth quadrant. And in the fourth quadrant again, cos ratio is positive. Here it was sine, that's why it will be negative. But since odd number, again I am telling you, this one is 3 is odd number, that's why the ratio will change. And sine goes to cos, that's why it is cos 30 degree. But the fourth quadrant, sine ratio will be negative, that's why it is minus cos 30. And minus cos 30 means minus root 3 divided by 2. So this is the result of sine 300 degree. You can break in two ways. Either it is even multiple of 90 degree or it is odd multiple of 90 degree. So ultimately, in the both way you see, you have same result, minus root 3 by 2. Here also minus root 3 by 2. Okay. So example 1 is over. Example 2. Sec 420 degree. Sec 420 degree. This equal to sec. We can break 420 degree like 5 into 90 degree. Suppose 5 into 90. 5 into 90, 450. 450 minus 30, that is 420 degree. Here you see 5 is odd number, that's why the ratio will change. So sine goes to cosec. Cosec. It will be cosec 30 degree. Then you see by the ASTC rule whether it will be positive or negative. For that one, you 5 into 90 degree. So starting from this axis, positive direction of x-axis, go 5 times of 90 degree. 1, 2, 3, 4, 5. Up to here is 5 into 90, then minus. That's why it is back. So you arrive at the first quadrant, and the first quadrant we know all trigonometric ratios are positive. That's why result will be positive. So ultimately only cosec 30 degree. And the value of cosec 30 degree, since sine 30 degree is half, that's why cosec 30 degree is 2. So result is 2. That is the value of sec 420 degree. This is 2. Okay. Question number 3. This is cosec minus 1410 degree. In the previous video, I told you about the negative angles, trigonometric ratio of negative angle. Since it is cosec minus 1410, like cosec minus theta, and cosec minus theta means minus cosec theta. That's why first of all here is minus cosec 1410. Now let us break the angle 1410. Cosec 1410 we can break 16 into 90 degree. If you break 16 into 90, then it will be minus 30 degree, because 16 into 90 minus 30 degree. Let us see 16, the number 16. 16 is even number, and since it is even number, the ratio remains same. And whether it will be positive or negative, that one can be calculated. You move from 16 times 90 degree, 1, 90, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Up to here it is 16, 90, then minus 30, that's why back again. So we arrive at the fourth quadrant. In the fourth quadrant, cos positive, since here is cosec, it will be negative. So that negative sign, and already here it is minus, 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 it will be plus. So result will be cosec 30 degree. And cosec 30, again this is the opposite of sin 30, sin 30 half, that's why cosec 30 2. Let us take another example, cot minus 15 pi by 4. So cot minus 15 pi by 4. You see, again here is cot minus theta. So cot minus theta means minus cot theta. That's why this will be, first of all, it is minus cot 15 pi by 4. Okay. Let us break the angle 15 pi by 4. This is equal to minus cot. You see, we can break it. Suppose 4 pi minus pi by 4. 4 4s are 16. 16 minus pi. This is 15 pi by 4. This equal to. Now you know it is pi. Pi means 180 degree. Ultimately 2 into 90 degree. So 2 into 4, it becomes 8 into 90 degree. Again 8 is the even number. Since it is even number, that's why ratio remains same. Then whether it is plus or minus, again you see the ASTC rule. 8 into 90. Let us start from x-axis. 890. 1, 2, 3, 4, 5, 6, 7, 8. Up to here is 890. Then minus pi by 4. Pi by 4 means 45. So minus, that's why it back. Again we arrive at the fourth quadrant. In the fourth quadrant, cos positive, since here is cot, that will be negative. So that negative and negative, ultimately result will be positive. So it becomes cot pi by 4. And you know cot pi by 4, this is the opposite of 10 pi by 4. 1045. 1045 by 1. So cot 35 1 by 1. Ultimately result is 1. Another kind of question, like if you suppose sin x is given. Sin x equal to 3 by 5. And x lies in the second quadrant. We are to calculate the value of other trigonometric ratios. You know the trigonometric identity. So main three identities are sin square theta plus cos square theta equal to 1. Another one is 1 plus tan square theta equal to sec square theta, and 1 plus cot square theta equal to cosec square theta. Using these three trigonometric identities, you can calculate all other trigonometric ratios whenever the value of one ratio is given. Okay, let us see. Here is sin x equal to 3 by 5. We are given sin x equal to 3 by 5. You know the formula, sin square theta plus cos square theta equal to 1, since sin square x plus cos square x equal to 1. Just putting the value of sin x, it will be 3 by 5 whole square plus cos square x equal to 1. So from here cos square x equal to 1 minus 3 by 5 whole square, that is 9 by 25. This becomes, taking LCM 25, 25 minus 9, it is 16. Therefore, cos x equal to root over 16 by 25. Dear students, you see, root over 16 by 5 have two values. One is plus 4 by 5, another is minus 4 by 5. Now, whether it will be plus or minus, that one, to calculate the value of that one, you see where x lies. X lies in the second quadrant, and you know in the second quadrant sign ratio is positive and all other ratios are negative according to the ASTC rule. That's why, since x lies in the second quadrant, the result must be negative. So this will be minus 4 by 5, but here you have to mention x lies in the second quadrant. X lies in the second quadrant, that's why cos x equal to minus 4 by 5. If cos x equal to minus 4 by 5, cos opposite is sec, that's why we can calculate directly sec x equal to minus 5 by 4. This is the value of sec x. We are given sin x equal to 3 by 5, and just we have cos x. Cos x equal to, since cos x equal to minus 4 by 5, and you know tan x. Tan x means sin x by cos x. Tan x equal to sin x by cos x. So putting the value of sin x and cos x, sin x equal to 3 by 5 divided by minus 4 by 5, 5 cancel, so result is minus 3 by 4. If it is tan x equal to minus 3 by 4, its opposite, that will be cot x. Cot x equal to minus 4 by 3. So this is the value of cot x. So question, we are given sin x equal to 3 by 5. That's why its opposite, sin opposite is cosec. So cosec x equal to 5 by 3. In this way, we can calculate the all other trigonometric ratios whenever one value of one ratio is given. Let us see another example. Cot x equal to 3 by 4, x lies in the third quadrant. We need to calculate all other trigonometric ratios. But main point is here, you remember, x lies in the third quadrant. And in the third quadrant, according to the ASTC rule, ASTC, tan is positive. Since tan is positive, its opposite cot is also positive, then all other ratios must be negative. So let us say cot x equal to 3 by 4. Therefore, we can write directly tan x equal to 4 by 3. Now, tan x is known 4 by 3. One relation, 1 plus tan square theta equal to sec square theta. That's why I can write, since 1 plus tan square x equal to sec square x, thus putting the value of tan x, 1 plus 4 by 3 whole square equal to sec square x. So it is 1 plus 16 by 9 equal to sec square x. So this will be 9, taking LCM, 9 plus 16, 25 equal to sec square x. So sec x equal to You see sec x equal to root over 25 by 9. Root over 25 by 9, this is 5 by 3. But this result must be negative because in the question it was given that x lies in the third quadrant. And in the third quadrant, only 10 positive and cot positive, other ratios are negative. That's why we have to write here minus 5 by 3, comma, since x lies in the third quadrant. Okay. Since sec x equal to minus 5 by 3, its opposite is cos, therefore we can write cos x equal to minus 3 by 5. Thus we have cos x equal to minus 3 by 5. Another relation, sin square theta plus cos square theta equal to 1. So applying this relation, sin square x plus cos square x equal to 1. Putting the value here, sin square x plus minus 3 by 5 whole square equal to 1. This implies sin square x equal to 1 minus, this will be 9 by 25. So taking LCM 25, it is 25 minus 9, 16. Therefore, sin x equal to, the result will be either it is plus or minus again. According to ASTC rule, x lies in the third quadrant, that's why sin x will be negative. So therefore it is minus 4 by 5, since x lies in the third quadrant. And since sin x equal to minus 4 by 5, therefore cosec x, its opposite cosec x equal to minus 5 by 4. So these are the values of other trigonometric ratios whenever one ratio is given, and the quadrant where the angle lies, that condition also given. According to the quadrant, we can calculate all other trigonometric ratios.